While most drone pilots are competing for $150 to $200 real estate jobs, there's a pilot in Iowa who just completed a 2,400-acre agricultural survey in 6 hours that would have taken a single drone 4 days, using 8 drones simultaneously controlled by one person. This isn't science fiction. This is swarm drone operations in 2026, and it's completely changing the economics of commercial drone work. I'm going to show you exactly what swarm operations are, which commercial applications actually make money right now, what equipment and software you need, and the honest truth about the learning curve. Because this isn't as complicated as it sounds, but it's also not plug and play. And at the 8-minute mark, I'll break down the exact ROI calculation that shows you when swarms make financial sense versus single drone operations. Swarm drone operations means coordinating multiple drones, typically 2 to 20, from a single control station to complete missions faster, cover more ground, or capture simultaneous perspectives that one drone can't achieve. This is different from just owning multiple drones. This is autonomous coordination where the drones communicate with each other, avoid collisions, and execute complex missions with minimal human intervention once the flight plan is set. According to a 2024 study by the Commercial Drone Alliance, swarm operations reduced project completion time by an average of 62% compared to single drone operations for projects over 500 acres. But here's what most pilots don't realize. The time savings isn't the only advantage. You're also getting simultaneous multi-angle data capture, redundancy if one drone has an issue, and the ability to tackle projects that are literally impossible with a single aircraft. Now here's where the business opportunity gets interesting. Let me break down the 5 commercial applications where swarm operations are actually generating revenue right now. Not in the future, not in testing, but deployed and profitable in 2026. First, large-scale agriculture. Multi-thousand-acre farms need crop health monitoring, prescription mapping, and yield prediction. According to Agri-Drone Industry Report 2024, farms using swarm operations for crop analysis reduced survey costs by $8 to $12 per acre, while cutting time by 70%. Typical project, 2,000-acre corn operation, 6 drone swarm, completed in 1 day versus 4 days with single drone. Client pays $6,000 to $8,000 for the full survey. Second, construction progress documentation. Large construction sites, think commercial developments, infrastructure projects, solar farms, need weekly or monthly progress documentation from multiple angles. Swarm operations let you capture the entire site from 4 to 6 perspectives simultaneously, delivering a complete as-built condition in 2 to 3 hours instead of 2 to 3 days. Industry rates, $3,500 to $7,500 per survey depending on site complexity. Third, search and rescue operations. When someone is missing in wilderness, time is everything. Swarm operations can cover 10 times the area in the same time frame, dramatically increasing find probability. According to the National Search and Rescue Association, agencies using coordinated drone swarms reduced average search time from 18 hours to 4 hours in wilderness scenarios. This isn't a service you bill hourly, it's emergency response contracting with government agencies. Typical contracts are $25,000 to $75,000 annually as on-call capacity. Fourth, large event coverage. Concerts, festivals, sports events, and corporate gatherings want dynamic, multi-angle aerial footage. A 3-drone coordinated operation delivers content that would require multiple pilots, multiple missions, or complex post-production to achieve with single drones. Pricing, $4,000 to $12,000 per event, depending on duration and complexity. Fifth, infrastructure inspection at scale. Utility companies, railways, and pipeline operators need to inspect hundreds of miles of infrastructure. Swarm operations let you deploy multiple drones to inspect parallel runs or different aspects simultaneously. Visual, thermal, LIDAR. A Texas power company reported 85% reduction in inspection time using 5 drone swarms for transmission line surveys. Project rates, $15,000 to $40,000 depending on linear miles and sensor requirements. Now, if you're looking at these numbers and wondering how to actually price your services, when you're stacking multiple drones, whether it's worth the equipment investment, how to structure your proposals. I've built a free tool called the Drone Niche Profit Calculator. It includes a swarm operations ROI calculator that shows you the break-even point based on your local market rates and project frequency. Link is in the description and pinned in the comments. Grab it after this video. So those are the applications. Now let's talk about what it actually takes to do this. Here's the honest breakdown of what you need to run swarm operations. First, the drones. You don't need identical drones, but you need compatible drones that can run the same mission planning software. Most operators start with 2 to 3 drones of the same model, then scale to 5 to 8 as projects demand. Entry point, 2 to 3 DJI Mavic 3 enterprise units at $6,500 each equals $13,000 to $19,500 equipment cost. Second, mission planning software. This is where the coordination happens. The major platforms in 2026 are UgCS by SPH Engineering, which supports multi-drone missions and collision avoidance for $2,500 per year. DroneDeploy Enterprise for mapping and agriculture at $3,600 per year. And DJI FlightHub 2 if you're in the DJI ecosystem at $590 per year per drone. Most professional operators use UgCS or DroneDeploy for the advanced coordination feature. Third, ground control station. You need a reliable tablet or laptop that can handle real-time data from multiple drones. Budget $1,000 to $2,500 for proper hardware. Fourth, Part 107 waivers. Here's the legal catch. Operating multiple drones simultaneously requires specific Part 107 waivers from the FAA. You can't just launch 5 drones under standard Part 107. You need waivers for operations over people if applicable, operations from a moving vehicle if applicable, and visual line of sight if using extensive autonomous operations. Processing time, 60 to 90 days. Success rate for properly documented applications, approximately 75% according to 2024 FAA data. Total startup cost for professional 3-drone swarm operation, $20,000 to $30,000 including drones, software, hardware, and training. That sounds like a big investment. So when does it actually pay off? Let's run the real numbers. Single drone operator doing agricultural surveys charges $4 per acre, completes 500 acres per day max. Revenue, $2,000 per day. Days needed for 2,000 acre farm, 4 days. Total revenue, $8,000. Time invested, 4 days. Now let's look at the same operator with a 4-drone swarm system. Charges $7 per acre, premium for speed and multi-sensor capability. Completes 2,000 acres in 1.5 days. Total revenue, $14,000. Time invested, 1.5 days. That's 75% more revenue and 63% less time. But here's where it gets really interesting. Your cost per project only increases by about 30%. Extra batteries, slightly more travel logistics, while your revenue increases by 75%. According to industry data from the Agricultural Drone Operators Association, swarm operators report profit margins of 55 to 65% on large projects compared to 35 to 45% for single drone operations. The break-even point? Most operators recoup their swarm investment in 8 to 12 projects. If you're doing one large agricultural or construction project per month, you're looking at break-even in under a year, then significantly higher margins moving forward. So that's the financial case. Now let's talk about the actual learning curve. If you're already a competent Part 107 pilot, getting proficient with swarm operations takes 40 to 60 hours of dedicated learning and practice. Phase 1 is software training, 15 to 20 hours learning mission planning software, understanding autonomous waypoint systems, collision avoidance parameters, and multi-drone coordination logic. Most software platforms offer certification courses. Phase 2 is simulation practice, 10 to 15 hours. Before you fly multiple expensive drones, you practice in simulation. Both UgCS and Mission Planner offer simulation modes. This is where you learn coordination timing, safe separation distances, and emergency procedures. Phase 3 is actual flight training, 15 to 25 hours. Start with 2 drones, master the basics, then add a third, then more. Most operators report confidence with 3 drone operations after 20 flight hours. Critical skills you need: ability to monitor multiple video feeds simultaneously, quick decision-making when one unit has an issue, strong understanding of airspace and obstacle avoidance, battery management across multiple aircraft, and data organization. You're now managing 3 to 10 times the files. The hardest part isn't the flying, it's the mission planning and data management. The drones largely fly themselves once programmed correctly. Now here's what nobody tells you about swarm operations. Let's be real about the downsides. First, weather sensitivity multiplied. If conditions are marginal for one drone, they're marginal for all. You can't fly 4 drones in 15 miles per hour winds if your threshold is 12 miles per hour. You're much more weather dependent. Second, complexity equals more points of failure. More drones means more batteries to manage, more potential technical issues, more pre-flight checks. What takes 10 minutes with one drone takes 30 to 40 minutes with 5. Third, higher stakes if something goes wrong. A crash with one $2,000 drone is bad. A coordination error that crashes 3 $6,500 drones is a $19,500 catastrophe. Insurance costs are higher. Expect to pay 30 to 50% more for swarm operation coverage. Fourth, client education required. Most clients don't understand why they need swarm operations. You have to educate them, which means longer sales cycles and more detailed proposals. Fifth, data processing demands. You're now processing 3 to 10 times the imagery. Your computer needs to be robust, your storage needs to scale, and your processing time increases. Budget for powerful hardware and cloud processing subscriptions. These aren't deal breakers, they're just realities you need to plan for. Here's the bottom line. Swarm drone operations aren't for everyone. If you're doing real estate, events, small inspections, single drone work is perfectly fine and profitable. But if you're targeting large-scale agriculture, major construction projects, infrastructure inspection, or search and rescue contracts, swarm operations give you capabilities and margins that single drone operators simply can't match. Before you go, I want to know, if you were going to invest in swarm operations, which application would you target first? Drop a comment below with either agriculture, construction, search rescue, events, or infrastructure. Just one word. I'm curious what markets you see the most opportunity in. Now, if you're seriously evaluating whether swarm operations make sense for your business, I've put together the Drone Niche Profit Calculator. It's completely free. Link is in the description and pinned in the first comment. This tool does 3 critical things for swarm operations specifically. 1, it calculates your break-even point based on your local market rates and how many projects you realistically expect per month. 2, it compares profit margins between single drone and swarm operations for each of the 5 commercial applications I covered. And 3, it shows you which equipment packages make sense at different revenue levels. You don't need to buy 8 drones on day 1. Grab it right now while it's fresh in your mind. Link is in the description and pinned at the top of the comments. Swarm operations are where commercial drone work is heading. The question is whether you're going to be ahead of the curve or watching others dominate these high-value contracts. Thanks for watching. I'll see you in the next one.